Okay, I want to talk about my N-scale train set that is being controlled by the Raspberry Pi. So this is a complete DC N-scale train system that is controlled completely by a Raspberry Pi, automated. And if you've seen any of my videos before, I was trying to figure out how I could do this by sensing the train with a flashlight and photoresistor. And now what I've done is I've updated my train set now with infrared sensors. So if you look right here, that's a pair of transmit and receive of infrared, and I've got those scattered around. I've got a couple over there, got one over here. Here's where the trolley can be sensed when it reaches the end, and the Raspberry Pi then can shut off the power to the trolley, let it sit there for a while, and then reverse the power to have it come back to the beginning and stop at the other end. Alright, so I've got those infrared sensors, and I've got the Raspberry Pi that is looking at those and then telling the track what to do in order to control the trains. Now here we have the steam engine, the passenger train, and now it's being told to go to the station, and then that sensor right there signals that the train is at the station, then the Pi stops it. Alright? And then now the diesel freight train can be controlled to run on the track that the steam engine was running on before, making sure that we don't get any collisions. So now you'll see this guy will be controlled by the freight train pretty soon. There it goes. Switches. And now the next time that freight train comes around, it will go ahead and go on the inner loop. So what have we got controlling this thing? Well, so we've got the Raspberry Pi here. That guy's about 35 bucks. There's a big bus that takes it over to the circuit board, and I've got 5 LEDs here, 1 LED per sensor, and you can see this red LED is lit because the passenger train is at the station. Then we've got these yellow LEDs, those are telling us that the trolley is running, and if you saw this, one of these yellow LEDs sensed that it had reached the end and told it to stop, and that's why these guys went off. Alright, now that green one is on the back of the inner loop, and that one was telling the freight train to switch the track. And so then let's see, what else have we got? We've got this chip right here. That's an expander chip, port expander. That takes the limited number of IOs I had on this Pi to expand them enough so that I could have enough outputs to control the track and enough inputs to put sensors around. So just with these two little wires here, you can drive this chip and end up with an extra 16 IOs. Alright, so port expander, that was like $3. Then we drive this motor driver module. That guy is driving the trolley either forward or backward or stopped. And that's normally used by robots. That's from Virtuobotics. That was like 17 bucks. Then we've got these set of relays. Every pair of these goes to a switch, a track switch. So you fire one of these guys high and it'll make it go straight. Fire the other one high and it'll go low, turn. And so you got a pair of those for each one of the track switches. Alright, and that's about 12 bucks for that guy, I think. And that came from SaneSmart. And the infrared sensors came from SparkFun, a couple of dollars for the pair of those. Those LEDs, you can get about 50 of those LEDs for about $5, $8, somewhere in there. And then we've got this other thing, this new edition, which is a wireless receiver. So that wireless receiver comes from Adafruit, and for that wireless receiver and this key fob, I can control the train manually. So this key fob and wireless receiver cost a grand total of $12, and I'll show you this later. Then we've got the program. Here's the program running, and you can see there's some counters getting decremented, and so the counter is decremented by watching the sensors, and when certain sensors fire, it decrements the counter, and when it decrements it, it tells some track switches what to do. And when this particular counter, the X counter, gets all the way down to 1, it switches the track so the passenger train will go to the station, and then at the station it senses as well that it's there, and the counter goes to 0 and it stops. And the trolley is running independently on a separate thread of program. And so here we go. We're going to get close to where the passenger train now should be going to the station. And it does, and it stops. And we'll see that guy control the rest of it. Alright, so now if we go back to our program, we'll see that the train is at the station, and now it starts another counter, it's a Z counter, decrementing that based on what the freight train is doing. So the freight train will run around on different patterns of the tracks, switching straight and turn, and after it's done decrementing all the way down to 0, then it lets the passenger train take off again. Alright, so that's everything with this, and you can see that really pretty cheaply you can build your own DCC system out of regular engines and some pretty cheap electronics. Now, I wanted to point out something else though. So I'm using my laptop to connect into the Raspberry Pi, but the only reason I'm doing that is I have a laptop and I can connect into it with this USB. So the laptop gives me a monitor, a keyboard, and a mouse, and if you don't want the USB, you can always buy a separate monitor, keyboard, and mouse for the Pi, because the Pi does have USB connectors, and so you can connect those in directly. Alright, so there you have it. A Raspberry Pi controlled Model N scale train system, built pretty cheaply, and then let me show you, let's watch this. Here's where the freight train goes back on to the outside track, and then we will see that when it gets to a sensor on the bridge, it'll tell the Pi that it is cleared the switches and now let the passenger go. Okay, there it goes. Okay, now let me show you the function of the Key Fob. So, basically, that little wireless circuit receives the function of which key is pressed, and I pass that on to the Pi, and then with the Python program, I tell what I want the track to do based on which one of these buttons is pressed. So you can see here on the A button, if I push that, it switches to turn. or to straight. So it'll toggle between straight and turn. Then on B, toggle this guy between straight and turn. And then if I hit C, that guy there, we'll toggle between straight and turn. Alright, now what I can do is I can use this also to control the stopping and starting of the train. So here comes the steam engine. Let's have it go to the station, like that. And when it gets to where I want it, I'll stop it with this. There we go, stopped it. So how did I stop it? Well, these switches here not only switch the track from going straight or turn, but they also steer the electricity. So by switching this to straight, by hitting B, I shut off the power to the station, and that's why this guy stopped. Alright, now let's say I want to start it again. Let's let this freight train go by. So to start the passenger again, I'll just hit B. There it goes. Because I switched it to turn, and now the electricity powered up the station and it was able to go. Alright. So, let's see, I wanted to show you something else. Then I programmed, let's hit A back to turn. So I programmed D to make all of them straight. So let's make C straight, or turn. Okay, now I'm just going to hit D. See, I hit D and switched all of them to straight. So I call that like my reset. I hit D, all of them reset to straight. I wanted to mention another couple of ways to sense where the train is, so that it could follow the program on the Pi. This was recommended by Mr. Limygit or Mr. Limygit on a previous video. And what it is using a magnetic relay switch along with a magnet. So this is from Miniatronics. And what I've done here is I've wired a magnetic reed relay switch in series with a battery, a resistor, and an LED. So when this switch is enabled, you will see this LED light up. So if I get this magnet or the switch in proximity of the magnet, you can see the LED lights up. And it looks to me about ½ an inch. As long as they're within ½ an inch, that should do it. So what you can do then is you mount this reed relay switch underneath the track, and you mount a magnet underneath one of the trains, and whenever the train comes by with that magnet getting close proximity to the piece of track with the switch, then it'll flip the switch, and that can be sensed by the Pi. Alright? And what's nice about that is it won't be so obvious like I have with the infrared transmit and receive. So, but you do need to modify the piece of track and modify the train a little bit. But still, it's pretty invisible. Here's another way. For example, let's say I wanted to sense when the train goes over this piece of track right here. I could put an insulator here, put an insulator here, and then power this piece of track independently and put a sensor there. You can make a sensor out of a resistor and an op amp and sense when current is flowing in this small piece of track here. So when the engine rolls over here and is powered by this separate independent power supply, you can sense that and that can then be recognized by the Pi and run the program from there. And then that would be totally invisible. There's no modification to the train. All you need to do is put the circuit to sense the current in here, and of course that will be invisible too. So that's totally invisible way of putting a sensor. So there's a couple ways. I wanted to mention one other thing that I've added to the train system. This isn't completely done yet, but you can get the idea. I've wired a red LED and a yellow LED and a green LED through the port expander into the Pi. And then I've got a Python program that says turn the red LED on for 8 seconds, then turn the green LED on for 8 seconds, then turn the yellow LED on for 1.5 seconds, and repeat the routine. So in that way, this models a traffic light. And then, now that I've got a model of the traffic light, I can hook that up to something I bought here. This is, for N-scale, a pair of traffic lights, and this was $9. And I can have one of these guys wired on one direction of the intersection, and I'll have the other guy wired for the other direction of the intersection. And then when this one is red, telling the traffic to stop, this one can be green, telling the traffic in the other direction to go. So all I got to do is remove this mechanical switch here and wire this up to the circuit board controlled by the Pi, and now we've got a realistic traffic light for all model trains.